Today we will start our next topic, that is functions, right? How to write functions in C. So most computer programs, they are able to solve the real world problems that are much larger than the programs that we have seen now. Okay, so I have already given you some examples which are actually huge programs. Okay, and in general also, if you talk about any real world program that is, that people are using for solving real problem, okay, the programs are very large, as compared to what we have seen till now. Okay, so if the program size is too big, then it is always better to develop the program into smaller pieces. Okay, why it is better? Because it will help us to, debug the program more easily. The program is more readable, testability is more, reliable, right? And there are many more reasons. So this is called modules of this small pieces are called modules of that program, right? So it is always advisable to work in modules, to develop a big program into modules. And what do we mean by module? Module means smaller pieces. Okay, so there are smaller chunks of code, and each chunk is responsible of doing a certain task. And what we will do to make the huge program, we will combine these small chunks and make a bigger program. And this technique in general is known as divide and conquer technique. Okay, and this is a very well known technique. Whenever you will learn DSA or design and analysis of algorithm, there is a lots and lots of algorithm that you will see which are based on divide and conquer paradigm. Okay, so what do we mean by divide and conquer? We would like to divide the bigger problem into smaller chunks. We will try to make sure that these smaller chunks or modules are working fine. Then we will combine these smaller chunks to solve the bigger problem. Are you following me? Okay, so modules in C, this modularity can be achieved using functions. Am I audible?
Yes, ma'am.
Yes, ma'am.
Right, so these modules are called functions. Okay, in C, this modularity can be achieved using functions. Now, these functions we have already seen. Okay, there are programs where we have used functions. Okay, like printf, scanf. Okay, all these functions we have already used. So these functions are defined in C standard library. Okay, so what I would like to mention here is this: C programs are written by combining either user defined function or predefined function or prepackaged function. Prepackaged function means the functions which are defined in some standard library of C. Okay, and there are new functions, or we can say user defined functions, the functions which as a programmer we will make. Okay, so all the C programs are actually collection of functions. The functions are either user defined or prepackaged function. We have already seen or used some prepackaged function, right? And there is one user defined function that we have seen. Can you name that function?
Constant wala.
Yes, ma'am.
Yes,
Define.
right? We have already seen we actually define this main function in all our program, right? So this is the function that user will define, and printf, scanf, power, all these functions we have used from some standard library. Okay, standard C library. This we have not defined. We don't know what is written, how these functions are implemented. Okay, we are just using the functions, but main function we will implement in our program, right? So in this we will see more of such functions, such user defined function, how to write function and how to work with this. Okay, so the standard libraries of C provide a rich collection of functions that can be used for mathematical calculation, string manipulation, input, output, character manipulation, and many other useful operation. And it is always advisable that if there is a function, right, if you know the function, just go ahead and use that function, right? So just familiarize yourself with all these functions which are already there, because this will help you to writing the entirely new program. It will help you reinventing the wheel, right? So if there are errors in the program that you will write, it is better always to use the pre-packaged function, so that all there are lesser chances of any error which could be occur. Okay, so it is always advisable to use such functions, and this will also make our program more readable, right? Because if you write the code to printing something on the screen, it is itself maybe one page long function. So it is always better to use printf function rather than writing the entire code of how to print it on the screen, right? Okay, so we have already seen printf, scanf, and power function. Now, the other function that we will write, okay, they are called programmer defined functions or user defined functions. Okay, both names are quite common. Now, how to do this? So the statement defining the function are written only once, and the statements are hidden from other functions. Okay, so we will see what is this. This is called prototyping. This is called function prototyping. We will see it a bit, after maybe 5-10 slides. We will see what is prototyping. Now, functions are invoked by a function call, which specify the function name and provide information as argument, right? That the function need to perform. For example, we have already used printf function, right? So we will just write one line, okay? And this is how we will invoke. And if we print hello world, this is called function invocation. We are invoking a function. We are invoking printf function, right? So functions are invoked by a function call. This is the function call. This is the function call. Okay, and this specify the function name. So printf is the function name, and along with the function name, there is also a need to provide the arguments, along with the function. This is to inform that what you have to print. So printf is used for printing on the screen, but in the argument we have to inform that what do you have to print on the screen. Okay, so in this line, this printf is function name, this hello world is act as an argument, and this entire statement is a function call to printf. Is it making sense? Yes or no?
Yes, ma'am.
Okay, now there is this hierarchy of functions. Okay, so there is the boss function. The calling function is called the boss function or the caller function, and the function which has been called is known as the worker function. So there is a notion of boss and worker, or you can say caller and called function. Okay, so when we call, so we write main function and then we write something, and at some point in time we call printf function with some argument, right? So main is called the boss function, and the function which is called inside it, that is printf, is called the worker function. Or main could be called as the caller function. Caller of which function? It is the caller of printf function, and printf is called function, right? So there is this hierarchy. Even printf can call other functions, right? So this is the hierarchy. Let me show you the diagram. Yeah, so this is the hierarchy. So there is one boss function, then there are worker function. This worker function itself will call other worker function. In this scenario, worker 1 will become the boss function and worker 4 will become the worker function. Okay, or this is called the caller of worker 4, and this is called function. Okay, and in this scenario, the boss function or the main function that is used is not aware of which other functions worker 1 is calling. and this is called hiding of unnecessary details. Okay, so the worker function may call other worker function and the boss will unaware of this. This is called hiding of implementation. Okay, this is called abstraction. The technical word used for this is abstraction. We are hiding unnecessary details from the user. We are hiding unnecessary details from the higher authorities. Okay, which they, I mean, who don't want to know anything about it, just don't know it. You have given me the task of printing, I will do it. Okay, and in that printing, doing that job of printing, whatever function I will need, I will call separately, but you don't have to worry about it, something like that. Okay, so this is called hiding of implementation, right? So now let's see some math library function. So math library function allow us to perform common mathematical calculation. We have already seen one function from math library, that is power function, which will actually take two arguments, right? Base and the exponent, base and the power. Okay, whatever we have to write. So if we write, say, x y, it is equal to x to the power y. Right, this we have already seen. Now the value of x and y we have to pass. Okay, so in the argument we can either use constant or we can use some expression. There is another function called square root function, sqrt, which is defined in math library. Okay, and what this function will do, this function will find the square root of whatever parameter or whatever argument you will pass inside this function. Okay, and so this is what written in the slide. So in the parenthesis, if there are more than one argument, we can separate it using comma as we did in power function, but square root will take only one argument, so we will just write it as it is. Okay, and when we type printf, it will actually going to print 30.0. Okay, so the argument is inside the parenthesis and function call is as it is, and we can use this function call anywhere in our program. Okay, so 900, it will return 30.00 actually. Okay, because we have done some string formatting that you have to print till 2 decimals of the number, right? Now, there is one important note here. All the functions in the math library return floating point value, okay, or return the data type double. Okay, so double and float both can be converted by %f. So all the functions in math library that return floating point value return the data type double. Okay, so this is also double, and the return type is also double, right? So we will see a little bit more about when we discuss prototyping about these types, right? So if you want to use a square root function, sqrt function, you have to include math.h library. If you want to use power function, again you have to include math.h library. And let me show you what are the functions. So these are the functions which are included in math.h library. There is a square root function, cube root function, right? You can directly find cube root by writing cbrt. Then there is exponential function, e to the power x, logarithmic function with different bases. Okay, then there is this absolute value, floating point absolute value. There is this ceiling function, which will actually round the number to the smallest integer or not less than x number. So for example, 9.2, ceiling of 9.2 will return the smallest integer, which is greater than the number. Okay, so it is 10. If you write minus 9.8, it will return minus 9, right? There is the floor function, which is just the reverse. It will tell you the largest integer not greater than x. So 9.2, it will return 9. For minus 9.8, it will return minus 10. Power function, we have already seen. There is this f mode function, which will tell us the remainder of x by y in the floating point number. Okay. then sine cos 10. Okay, these are geometric calculations that you can done using math.library. Right, so all these functions are defined in math.library. If you want to use any of this function, just try to include hash include math.h, right? And depending upon what is the requirement of that function, you have to pass the arguments. Okay, and these arguments could be expression also. So for example, suppose if C1 is 13.0, D is 3.0, F is 4.0, then you can pass this as an argument. So first this expression will get evaluated. First it will do 13.0 plus 3.0 into 4.0, right? And after evaluating it, whatever number or whatever answer of this expression, it will find a square root of that particular number. Okay, so the output of this expression is 25 and it will find the square root of 25 and it is 5. Is it clear? Any doubt in this? Any doubt till now?
No, ma'am.
All right, now let's see how we can make our own function, right? User defined function. So functions in C are actually allowing us to modularize the program. All the variables, now this is important, all the variables which are defined inside the function, they are called local variables. So here I am introducing one term, local variables. Okay, local variables are the variables which can be accessed only inside the scope of the functions in which it is defined. Right, so okay, so just remember this thing. In a couple of minutes I will let you know what are local variables, right? So what is the definition of local variable? Local variable are the variables that can be accessed only within the scope of the function where they are defined. Okay, after that function there is no nobody knows what that variable is, right? After that function, if you use that variable, you will get an error that this particular variable is not defined. Whenever you use that variable inside the scope of the function where it is defined, then only it is having, or then it will make any sense. Okay, so this is one thing that we will see, local variables. Now most functions have a list of parameters that provide the means for communicating information between functions. Okay, so the list is called parameters or the arguments. The function parameters are also local variables of that function. Okay, so this we will see in a minute. Okay, so let's see. Okay, so these are again some use of functions, why you have to use functions or why you have to make your program modularized. So there are several motivation for functionalizing your program. The one we have discussed, divide and conquer, which will actually make your entire code much more manageable, much more readable, much more scalable, and much more robust. If you want to add one more feature in your program, you just have to make another module and plug it in. Okay, there is no need to do anything else, right? Now another motivation is software reusability. If you are having an existing function for a certain task, you can use this function anywhere in your lifetime of your programming. If you make a function for, say, finding something, right, you can use this function anywhere. Whenever you do programming, you can use this function, so it will actually increase the reusability. Okay, and from this concept only the object oriented concepts were born, which you will see in C++, or maybe Java, not in C but in C++ and Java and C# and all, right? Okay, so for example, we have already seen this abstraction using printf, scanf and power. If you have to do it, there is a lot of things you have to keep in mind, right? But since we are already having one function, we can reuse this function whenever needed. So a lot many times we need to find the power, we need to take input from user, we need to take printf from printf to the user, right? If you write each time the entire code for this function, it is too much, right? We generally reuse the function. We have implemented it once, or somebody has implemented it once. We are just using this function using a single line of calling the function, right? So it will avoid the repetition of the code. Even in one program, if you want to print something 5 times, you can avoid this using functions. If you will make a function, you just need to write it one time and you can use it 5 times. Okay, so there is a strong motivation why we need to use functions, and it is an important, very important feature of C, that it provides modularity. It allows us to do so. Okay, all right, now let's have a look at the actual function. Again, there are some common or good practices that keep the function name much more understandable, right? So that from the function name only you could know what this function is doing. Okay, now let's see one small program. Let's write our own function. So suppose we want to make a program that we have to find the square to calculate the function, right? To calculate the number, we have to make the program to calculate the square of integer from 1 to 10, right? This is the program we would like to make. Okay, so we will do it using function. Is it clear? Is our aim is clear? We want to find the square and calculate the square and print the square of the integer from 1 to 10. Now let's see how we will make it. Okay. So this is the function prototyping. Okay, in a minute we will see what is this. For now, please ignore this line. Okay, let's just ignore this line. We will see it after some time. So what we will do, we will just include stdio.h. Okay, we will start our program. We will write main as usual, right? Now we have to find the square of how many numbers? 10 numbers. Okay, for that we need a loop. Okay, so we are having a counter variable x, which will run 10 times. We will use our loop. So suppose we are using for loop. We will initialize it. X is less than 10 plus x. Okay, now we have to printf the square function, printf the output. So we will write printf, and now here we are calling square function. This is the function call. Okay, this is called function call. This is the function call, right? Okay, now let's see how we define this function. So this is our square root function. This is our square function, not square root function, right? So square, we will pass, or we will make a copy of the argument, and then what we have to return, we have to return y into y. That is, whatever the number come here, we will say just square the number and return the number. Okay, now let's see again here. In the function call, in the first go, we will pass 1. Okay, so this will actually become square of 1, right? So it will call the function. Well, when our control comes here, it will first call the function. When this function is get called here, so this is the function definition. Here y becomes 1. We have mentioned int y. This y becomes 1. Are you following me here? For the first time when the function is called, and then it will come and it will return 1 into 1, that is 1. So it will return an integer value 1, and it will get printed. Okay, so the value of square 1 is replaced by 1. Okay, again x will increment and the value of x becomes 2. Then the next function call is square of 2. Square of 2. All right, then the control will go here. The value of y becomes 2 now. We will go inside the square function. 2 into 2, that is 4. 4 is returned, and then this entire thing is replaced by 4, and 4 is get printed on the screen, right? So now this block of code is function definition. This is called function definition. Okay, so this square function definition return the square of its parameter. Whatever come inside as a parameter, it will return the square of that number, right? And here this square x is function call. Here we are actually calling the function. How to write it? So this is our main function. These are the opening curly bracket and closing curly bracket of main function. So when you have to define your own function, after the closing of this main function, you have to define your function. Okay, so this is altogether one file in which the program is written. On line number 18, we are closing the curly bracket, means we are ending our main function. Okay, and after that, in next line, we are defining our new function, right? So this is how it will work. Now there are few important things that I would like to mention. Function prototyping. Okay, so let's discuss function prototyping again, and then we will again come back to this program, right? So I hope function definition is clear to all. This is the function definition. Is it clear? In function definition, what you need to write is this. So see what happened actually. Function square is invoked inside main function, right? And then function square receive a copy of x. Whatever is the value of x, it will receive that value, and y becomes that value. And accordingly, the function will work, right? So this will happen 10 times actually. Now, on line number 5, we have defined a prototype of a function. Now, what do we mean by prototyping of a function? Let's see here. When defining the prototyping of a function, what you have to mention, return type of the function. This is the return type of the function. What is the value that function will return? Name of the function, square is the name, and all the parameters that the function will take along with its data type. Parameters along with its data type. This is called prototyping. Why it is used? What is the why it is important? We will see. But this is function prototyping. So this line is exactly same as the line that we have written in the definition. Okay, in function definition, whenever you want to define the function, you have to mention the return type. If there is no return type, just write void. Void means the function will not return anything, or it will return null. Okay, so in this we write function will return int. Okay, and then the name of the function and all the arguments along with their data type. Now, if you remember, we have talked about local variable. Okay, local variable. So what is the local variable to a square function? Local variable is y. Okay, because y is defined within the scope of this function. If you would like to print y in main function, it will give you error. Okay, the name error, it will give you that this variable is not defined, because the scope of this variable is only inside this function. If inside a square you will write x into x, suppose, because we already mentioned that the value of x is say 1 for the first time, right? At that time, what will happen? If you write x here, it will give you again, the error that variable is not defined. Why it will give you the error? Because the scope of x is only within the main function. Okay, so x is the local variable of main function. Y is the local variable of square function. Am I making sense?
Yes.
Yes.
Okay, so if you want to define your own function, the very first thing you need to do is function definition. Okay, function definition is most important. So first you have to define the function. First you have to give the definition of the function, and this is the way to give the definition of the function. Just mention the return type, name of the function, all the arguments or parameters that it will take along with their data types, and inside the function do whatever you would like to make the function do, and then return whatever is suited for the program. Second thing, so this is function definition. Second thing, in your main program or wherever needed, you have to make the function call. When you are making function call, there is no need to write anything else. Just write function name and the parameters that are required. So if there is one parameter, you can pass it. If more than one parameter is required, pass all those parameters. Please remember to maintain the exact or pass the variables of same data type. Otherwise, it will give you the error. So if the function is asking for integer type argument, then x should be of integer type. Okay, so these two things should be same.
Ma'am, we should use function prototype 2 times.
No, this is not function prototype. This is the function definition. Function prototype, I will let you know. This is function definition. Okay. Now, what is function prototype? Function prototype is whatever is the first line of function definition. You can write it in the very beginning of the program before even the main function. This is called prototyping, and you have to put a semicolon here. Here, if you notice, there is no semicolon, right? This is entirely one block. This is one function. There is no semicolon after this, right? And in prototyping, what you have to do, you have to put the semicolon. Now, what is the use of prototyping? We will come to that. Okay. So let's talk about prototyping as well, and then I will again come to this program. So this is the format of function definition. Return value type, function name, list of parameters along with their data type, whatever the task you would like to mention, and you then in the last you have to return the appropriate value. Okay, fine. So if there is nothing to return, just indicate it using void. Okay,
हम एक बार पिछली स्लाइड बताना
this
इससे पहले वाला हाँ थैंक यू
is it okay? Now let me show you the prototyping actually. Okay, then the things will be much more clear to you. Again, we will come here. Function prototyping. Okay, yeah, this is the prototyping of the function, and then we will see few more program, right? So this is an important feature of C to prototype the function. Now this prototyping will actually, what it will do, it will allow the compiler to validate the function call. Okay, now what do we mean by this? So previously it is not there in the C, right? And now they have introduced it in the C. Now, what is the use of prototyping? So this is actually the prototyping, right? The function prototyping for, say, any maximum, if you want to find the maximum of 3 number, this is the function prototyping. It states, what this particular line states, it states that maximum take 3 arguments, and the type of those 3 arguments is of integer type, and the return type is int. This is all. This is everything that the prototype would like to mention. If your function definition differ from this particular thing, then it will give you the error. Right? So in prototyping, you are just mentioning that there is a function. There is a function. Okay. The name of the function is maximum. It will take 3 arguments. 3 arguments are of integer type, and there is a return type which is of integer type. Okay. Now, why it is useful, you may ask, right? So, sometimes it may happen sometimes that, you want somebody to enforce that you have to define the function in a particular way. Are you getting my point? So suppose, you are running a company and you would like that people will define the function in this particular way, and therefore this prototyping is needed. Okay, prototyping is actually validating that the definition of the function is exactly same as mentioned here. Okay, and one more important thing. Okay, so you all are aware of what compiler will do. Okay, suppose if you don't write this line and you will use a square function, okay, rest of the program is same. You will use a square function first, and then actually you are defining the square function. Then it will give you the error that square is not defined. Okay, so there are two options: either define your square function before main, or before calling it define your square function, or you can use function prototyping. This function prototyping will let the compiler know that okay, there is a prototype of this type and this is matching with the prototype, so definitely in later in the program I will get the definition of this square function. Now, are you following me here, what I have just told you?
Yes, ma'am.
Okay, so prototyping is used to make sure that the function definition will be there. Even if you forget to define the function, it will give you the error that you have not defined the square function. You have mentioned the prototyping, but you forget to define the function. So in that sense also, it is type of a cross checking. In the beginning you will define that okay, these are the function which I will like to define, and the format is this. So this is actually the format of the function. Okay, it will not contain any definition or any implementation part. It will just showing that this is the structure of the function. This is the name, these are the inputs it will take, and this is the return type of the function. Okay, so this is called abstraction. We are abstracting it out using function prototype. Okay, and since we have defined function prototype in the beginning, it does not matter wherever you would like to use this square function, you can use it and define it in the end of the program. Now I am open for questions. You can go ahead and ask me question related to this particular program.
Ma'am, for main function, why don't we function prototype?
For main function? Hello?
Yes, ma'am, for main function, why don't we put that function prototype?
Because see, main is little bit different. Main anyways you have to write, right? So is it possible that you forgot to define main?
No, ma'am.
So this generally never happens, right? So main is something, so C program is actually, equivalent to, like if you are not writing a main, then there is no C program. Okay, so these things are mandatory, but user defined things which in some program you will need, some program you don't need. In some program you will use a different format, in some other program you will use a different format. Depending upon that, we will use prototype. Even you cannot use main function anywhere before main. Okay, it is not making any sense. So anyways you have to start your program, writing your program with main.
Okay, ma'am.
Any other questions? So in next,
Ma'am,
yes, please.
ma'am, can we can we write the function definition before the main function?
Yes, that you can do. So these are actually blocks. You can put it anywhere in your program. So this is one block, which is actually consist of main function. This is second block, which consists of square function. Okay, order does not matter. You can keep square before main.
Ma'am, in that case, ma'am, we don't have to write the function prototype.
it is always advisable to write the prototype. It will not give you any error, right? If you write a square before and then write a main, it will not give you any error. Program will run perfectly fine. Okay, but it is mandatory to write, prototype if you are writing or defining the square function after main. In that case, it will give you error. But it is always a good practice to write function prototype. Any other question? So in this, we have seen three things: function prototyping, calling of the function, and definition of the function, right? And there is one more thing which is called local variables that we have seen. I hope all the concepts are clear now, at least these 4 concepts. Now let's make another program and see what will happen. So, okay, so there are some error prevention tips. Check that your function that are supposed to return value do so. Check that your function that are not supposed to return values do not return value. Okay, so return type is important. Sometimes, we just implement the entire logic, but we forgot to return that value. If we will not return the value, it will not go to the caller. Okay, caller function actually. Okay, the parameter list is comma separated. Okay, this we have seen. Specifying function parameter of the same time as double x comma y instead of double x comma double y result in a compilation error, right? So if there are 2 parameters, both are of double type, somebody will say, okay, let me write. So suppose there is a function sum of 2 double numbers. In prototyping, return type is double. In prototyping or in definition, students may write x comma y. These are 2 variable of double data type. This is wrong, right? In functions, prototyping and definition, you have to write double x comma double y. You cannot combine this. So this is again one common error that students will make. Placing semicolon after the right parenthesis enclosing the parameter list of function definition is a syntax error, right? So suppose this, if this particular line, this is a right line. If this is a prototype, you have to put a semicolon, otherwise it will give you error. If this is a definition, function definition, then semicolon should not be there. If there is a semicolon, it will give you error. And for obvious reason, you can understand why it is an error, right? So if it is a definition, it is expecting curly open and close curly bracket and some statements here along with the return type of double. If it is a prototype, it is just expecting one line along with the semicolon. Okay. Okay, defining a parameter again as a local variable in function is a compiler error, right? So for example, in this we have seen, if we say, okay, this is int y, and again suppose we are writing int y here, then it will give you error, because for this block y is already defined, right? So you cannot make 2 variable of with same name. Okay, you cannot define 2 variables with same name. So whatever written in the function definition is also the local variable for that, right? Okay, although it is not correct to do so, do not use the same name of a function argument and corresponding parameter, right? So it will not give you error, but don't use that. You will, if the function name is also sum and the parameter is also double sum, something like that. Don't do this. It will create unnecessary confusion, right? And this block is called a block or function body. When you open the curly bracket and close the curly bracket, so for some function, suppose, right? So this is called block of function. Defining function inside another function again is an error. Therefore, we have started our main function, we have closed the curly bracket, and then we have defined our square function. Right? It is not permitted to define definition of one function inside the definition of other function is not allowed. You can call this function, but you cannot define this function. Okay, so I think that is enough for this function prototyping we have seen. Okay. Yes, now there is one more important thing I would like to mention. So let us read out this slide. These are having some more concept. So there are three ways to return a control from called function to the point where the function is invoked. Okay, so if you remember, when I call square of say 2, once the definition is called, it will return 4, and this 4 will actually replace this. Okay, so control will again come exactly to the point where it left, right? And this is happening through the return statement. So if the function does not return any result, control is returned simply when the function ends the bracket. Okay, so if you don't write anything, if there is no return type or void return type, so there is something. Whenever the closing curly bracket is found, it will automatically get returned. The function is automatically get returned if the return type is void. Okay. Return simply the function ending right braces is reached by executing statement return. So either this, or if it finds just the return, then also it will return. If there are some result and you write return that result, at that time also it will return. So there are three ways when the function will return. It will return either by return semicolon, or by return expression, or by not writing anything, just closing the curly bracket, it will return. Okay, so this is how the control from called function is returned to the caller function. Okay, so return is having main type. The return value of main is used to indicate whether the program execute correctly. Therefore, the output is of integer type. Right, I have advised you to keep it as int type, but you can keep it as void also, and there is no issues, no error as such. But at the end, if you know the program returns 0, it means that the program run successfully and it terminated successfully, and therefore the value is 0. Okay, sorry. Okay, now let's make another function. If the value is non-zero, then the error is there, and depending upon the value, okay, the value is then the error code. So whenever you find the error, you can see there is some error code which will also come along with the error, right? And if there is no error, it will return 0, and generally 0 is not get printed, right? Okay, now let's do another program. Find the maximum of 3 number. Okay, so user will pass 3 number, and you know, it will return the function will return the maximum of those 3 number. So this is the function. Just have a look at it. What is the function prototype? We are expecting 3 integer values from user, right? And the return type is also integer, right? And then this is the calling function. So we are taking input from user, 3 numbers we have taken as an input, and then we are calling the function along with these 3 numbers. Let's see the definition. Inside the definition, what we write? We write, okay, int x, int y, int z. Okay, so this is the logic to implement the maximum of 3 numbers. So we will assume that x is maximum in the beginning. If y is greater than maximum, then max value become y. If z is greater than maximum, then max value become z, and in the end we are returning max. Okay, everything is of integer type. What are the local variables of x, y, and what are the local variables for maximum function?
Max,
X, Y,
X,
Y.
X, Y, Z, and
X, y,
maximum.
okay. And what are the local variables for main function?
Number 1, number 2, number 3.
Number 3.
So if you use max here, then it will give you error. If you use number 1, number 2, number 3 there, it will also give you error. Any question in this? In function definition, we don't put any semicolon, whereas in prototyping, we have to put a semicolon. I hope this is very clear to you. Okay, and this is only one function. You can write many more functions here. Okay, so instead of maximum, maybe you can write a minimum also, minimum of 3 number. Okay, and accordingly, you have to define everything. So you can write minimum of 3 number, and in the main function, you can say, okay, I would like to find maximum also and minimum also. Accordingly, you can make the suitable changes. Okay, so there is no limit that how many functions you can define in one program. You can define as many as function as you need. Right, so this is the output. Okay, so function prototype, let's talk something more about function prototype. So include function prototype for all the function to take advantage of C type checking capabilities, right? It will also help in type checking capabilities, because when we use the preprocessor directive to obtain the function prototype for standard library, functions from header of the appropriate library, or to obtain header containing function prototypes for function developed by you or a group of people, right? So if we see this, when we write hash include stdio.h, right, what actually it will do, it will include the header file. Okay, and what is written in the header file? There is this function prototyping, right, and the definition, which will make sure that whatever user will pass as a parameter, so it will help actually the compiler to do the type checking. The type should be matched, right? So therefore prototyping is important. And there is one more good practice, that parameter name are sometimes included in function for documentation purpose. Okay, so if you write int x, y, and z there, right, so it will also help you in documentation. Compiler has nothing to do with these names. It will not give you error. Okay, and the common error we have already discussed. If you forget putting semicolon after the prototype, again it is an error, right? So now the compilation error, the function call that does not match the function prototype is a compilation error. If in the function type you mention that the return type of the function is double, but while implementing or while defining the function, if you convert that type into int, right, the type into main, then what happened? It will give you a compilation error. Prototype should match exactly with the function definition. So this is also sort of a cross checking, right, that you have mentioned the proper data types. An error is also generated if the function prototype and function definition disagree. Okay, even the name disagree or number of parameters required disagree. So in prototyping you mentioned that it will take 3 arguments, and in the definition you take only 2 arguments, then also it will give you a compilation error, right? So this actually helps you in cross check the things. So in the beginning of the program, maybe you will write, okay, I will make a program which will take this many arguments and this and that. Okay, but while writing the program you forget some things. So the prototyping will help you to remember those things. So it is kind of a documentation as well. Okay, Now let's see argument coercion and usual arithmetic conversion rules, right? So this is another important feature of function prototyping is coercion of arguments, that is forcing of arguments to appropriate type. Now this is very important point. Somebody is asking why to use prototype. Maybe we can define the function beforehand before using them, so then there is no need, right? So now let's see one important feature. Now, for example, that math library, we have seen a square root function. Okay, and in the library it is defined, they have specified that the square root function will take double as an parameter, right? Now, for example, the math library can be called with an integer argument, even though the function prototyping specify a double parameter, and the function will still work correctly, right? So for example, if you give 4 and it will evaluate 4 and it will print this, right? As per the string formatting option, it will print 2.000. The answer is correct, right? Now what happened actually? The function prototype causes the compiler to convert a copy of an integer value to the double value before the copy is passed to the square root function. This is called, this feature, this is an important feature, this is called argument coercion. Okay, they will apply simple arithmetic rules, and if the conversion is possible, they will do it. They will not convert a string into integer and something like that. But if these small conversions are possible, then definitely the compiler will do so before passing it or before calling the square root function. So even in your square root function, you will pass an integer type. What actually the compiler will do, the compiler will convert that integer value into double value, and then it will call the square root function, right? And this will help because the prototyping we have mentioned that it will take a double as an argument. Okay, if you don't write prototype, then directly there is a function call. There is no other way to let the compiler know what is the data type of the arguments it is needed. Am I making sense here? Are you getting my point?
Yes, ma'am.
Okay, so therefore prototyping is quite important feature, and I think you always have to use it. Just make it a habit of using the prototyping before the beginning of your functions, right? Okay, so yes, some conversions are allowed, some conversions are not allowed depending upon the type, right? So if in the square root function, int can be converted into double very easily, right? However, when a double is converted into an integer, it truncates the functional part, and therefore it is actually changing the original value, right? So this actually changed the result. Okay, so I mean